Hello everybody, today I will show you how to use Grasshopper to model spheres with like an interesting pattern on it. And then you can maybe print these spheres, use them as Christmas ornament, as decoration for your Christmas table, and just have a good time with it. I hope you like it. Let's go. Let's see, so this is Rhino 7. This is Grasshopper. Here are all the different algorithms that I plan to share in the upcoming Christmas ornament video series. But let's start with one of the simple ones. Okay, so what we need is the geodesic dome. Or geodesic, I'm not sure how to pronounce it. It's part of the Parakeet plugin, right? So if you Control-Alt click on the component, inside Grasshopper, it will show you where it can be found. So this is the Parakeet plugin, and here we have the dome, and it automatically places like this geometry in the center of your workspace. And we will define the radius to be 50 millimeters because that's the units that I'm using. And dome frequency basically means the subdivision level, right? So the higher, let's see, let's put 2 maybe. So this is now a little bit less dense, and I think this will be a good choice, but you can play around with it. You can even start with 1 if you have not the strongest computer potentially. So yeah, just be aware that basically the subdivision level will define how fine your pattern appears on this sphere. All right, the next thing we need is face boundaries. So what we have here now is the mesh geometry. And what we want is the face boundaries as curves, as lines, so we can do something with them. So we take the mesh and plug it in. So that now we have these lines. If we use the panel, it says that we have, let's say, how many? 320 lines, polyline curves. So each individual face is just a single line, right? So it's not like split all the different edges of the face into different lines. So it's already like considering the consistency of the mesh. And we also need these face normals. So we can derive the centers and the normal vectors from our mesh. Okay, so now we have the centers, and we want to move those centers along the normal vector. So they are here, and now they move in, right? The normal vectors are like perpendicular to the surface or to the face of the mesh. And if we move along that, I think base motion is just like one regular value. Then we move the points in. And what we do next is we say extrude point. And that basically takes these points and face boundaries and creates an extrusion towards the center, right? So from the boundary to the center point that is moved inwards, and you generate this beautiful star-shaped geometry. I think it's perfectly fitting with the Christmas theme, and it looks nice. And then basically you still have to make sure that you join the things. So even though we started with the mesh, the extrusion gives us a brep, an open one. So we want to make sure that it's one geometry, and now we have one closed brep. We can bake it. We don't need to group or anything. And this is our geometry now. And here you can do whatever you want with it, right? You can print it. You can like model a little hook. So you can hang it onto the tree, a little platform, or whatever you feel like could be nice for this one. I think it looks really cool. But let's see if we can add a little bit more dynamic to the whole thing. The first one would be, maybe we want to be able to control how deep the extrusion is supposed to go. So we just add like a multiplication. So we take the normals and then maybe we multiply by a factor, and now we have, let's say, increased the amplitude of our normal vector, and that way also we shifted the points further in or out depending on where we go, and that way we can create like more intense, maybe just look at it. So this would be one, so it goes really deep inside, and in comparison like one that we had at the beginning. So that looks quite different already just by playing with the value. And if you go smaller than 1, it's just flat, but you can also, let's say we want negative. Maybe just give it some value. And now this value is also in the other direction. And now it will protrude from the sphere and give you a completely different appearance again, right? So now it has much more structure, like rough. And let's look at it in the rendered mode, and then we immediately see that, yeah, it's quite a different styling that we can achieve with this simple algorithm. There's really nothing to it. We can still spice it up further, we'll play with the basic point attractor. So what do we need? We want to populate geometry. So we have our dome as our geometry, and we want to populate it maybe with 2 points. So at random. I think that's nice, quite opposite. That's cool. And then we take the pull point command to get the center point, to get the distance. Now we have a list of distances, right? For all the center points to those points. And from here, we basically remap boundaries, bounds. Okay, so we have the distances. We put them here. We have the values. No, these are the values. We have the domain that these values encompass, and we have a target domain, which is by default from 0 to 1. You can also just construct your own domain if you want to have more control, but for our purpose, this is all right for now. Then we can take a graph mapper, plug these in, take this one as an example, and now we will remap again. But this time we construct our own domain, because now the values also just go from 1 to 0, but we potentially want to be able to control where they go. And I don't know, let's do 1.2. I'm not sure what scale is good for this. We will figure it out. So now we remapped our values, right? So these were the original distances, 59, like quite high values. Then we remapped them once. So they were all between 1 and 0. Now we use this graph mapper. and then here they come out slightly shifted according to the graph. And now we do remap again according to our new constructed domain, and then we get these values here. And this, let's say we shift all of it to the front to make the connection. And we multiply with our normal vectors, and we move stuff. And what you are supposed to see is that based on the distance, because that's where we started, right? Based on the distance to the 2 points that we generated here on our geometry, the depth is supposed to change. And now we can also still make further and finer adjustments with our graph mapper. And in the preview, it's not that visible, but if we bake it, I think the effect becomes more apparent. Okay, this is actually still a lot. I would like a little bit less extreme. Yeah, I think this is better. And now if we look at it in the rendered one, then we see that when it gets closer to the points, then the depth of our extrusion reduces. And the further it goes from these points, the deeper it goes. So that way you can create like a really nice natural transition and a cool effect. You can also just increase the number. Maybe if you don't want to bake all the time, you can also just make a custom preview of the geometry. And let's delete this one. And now it shows right away. Okay, so just for an example, let's increase the points that are being used to calculate this, right? So these points are here. So obviously now, because it's more points, there will be, the distances will be closer. So overall, the effect will, yeah, be washed out a little bit. You can still adjust, maybe that way it's a little bit more easy to understand and see the effect. And you can also still go in, this might take a little bit longer, and say you want to have it more fine. So I go up one subdivision level, and there you have also a little bit more resolution for these effects to show, right? Because you have much more faces and much more face extrusions. So I think that's quite funny. Or you can also always play with the seed, right? So maybe you like 4 points, but you want them to be located differently on the sphere, on the dome. Maybe 4 is a little bit too much actually. The effect is more appealing if the contrast is also visible. Right. So this was it, like the first Christmas ornament that you were modeling inside Grasshopper. I hope it's easy to understand. If not, just drop the questions in the comments and I try to help you out as much as I can. But overall, this is pretty much straightforward. This point attractor is like a very common way to use to create patterns that fade gradually towards a certain edge, curve, surface, or whatever. So you have a little bit more control of the patterns, and they don't just follow a linear approach and just go deeper or less deep, just on a straight line. All right, let's go. Thank you.